Question from coordination compounds. Atomic number of chromium and iron are respectively 24 and 26. Which of the following is paramagnetic with the spin of electron? So we need to find which of these complexes will be having unpaired electrons in their orbitals. So that will be responsible for paramagnetic nature. So let us take one by one. First one is CrCO 6 times. Let us find the oxidation number of chromium in CrCO 6 times. CO is a neutral molecule, so zero oxidation state, and there is no overall charge. So chromium will also be having zero oxidation state. Atomic number of chromium is 24, and we can represent it using the configuration argon 3d5 4s1. So 3d5 4s1 is the outer electronic configuration. This is 3d, 4s and 4p. 3d5 1, 2, 3, 4, 5 and 4s 1. Here, since chromium is in its zero oxidation state, no change is to be made. But the approaching ligands are carbonyl groups. So CO, carbonyl is a strong field ligand. CO is a strong field ligand. So what it does is it will pair up the electrons. The 5 electrons in the 3d orbital and 1 electron in the 4s will come together and it will pair up, and they will pair up. Let us see. 6 electrons. Electrons will pair up like this. So no unpaired electrons. So the complex will be diamagnetic. CrCO 6 times will be diamagnetic. Then these positions or these vacant orbitals will be filled up by the coming carbonyl group. They will, that is this 3d, 2 of these d orbitals, 1 s orbital and the 3p orbitals will give a d2sp3 hybridized orbitals, and they will give d2sp3 hybridization of the in the complex, and the complex will be diamagnetic. That is what we are asked to find. So we will take the next chromium complex again. That is CrNH3 6 times 3 plus. Let us see. Ammonia is again a neutral molecule, zero oxidation state, but it is having an overall charge of 3 plus. So chromium will be in its 3 plus oxidation state. Chromium will be Cr3 plus. So in the outermost electronic configuration, one of the 4s electrons and 2 3d electrons will go. Then only it will attain Cr3 plus oxidation state. So let us see the orbitals then. Three electrons are gone from the 3d5 4s1. So 4s electron is gone, 2 electrons from 3d is gone. So it will be left with 3 electrons in the 3d orbital. And the approaching ligand is ammonia, that is NH3. NH3 is a weak field ligand. Ligand is NH3. It is a weak field ligand. So it will not make the electrons pair up, and it will we giving a D2 sp3 hybridization. D2 sp3 hybridization, but there will be 3 unpaired electrons in its orbital. So this complex will be paramagnetic due to the presence of these unpaired electrons. Okay, next complex is FeCO5. Let us find the oxidation number of Fe in this carbonyl group. CO is zero oxidation state, no overall charge, so Fe is also in its zero oxidation state. That means argon 3d6 4s2 is the electronic configuration. If we can represent it like this. Six electrons in the d orbital. 1, 2, 3, 4, 5 and 6, and 2 electrons in the 4s. Now the approaching ligands are CO. CO, as we said earlier, is a strong field ligand. So what will it do? It will make these electrons pair up. That is, there are 6 electrons. These 6 electrons in the 3d orbital and the 2 electrons in the 4s will come together. They will pair up. Three D, 4s and 4p. They will come together and pair up means 8 electrons in the 3d orbital. This will become 3d8. And the remaining, that is 1d orbital, 1 4s orbital and the 3 4p orbitals. D sp3 hybridization. Are there any unpaired electrons here? No unpaired electrons. So FeCO5 will be diamagnetic. Let us take the next one, FeCN6 4 minus. Let us calculate its oxidation number. We'll write it here. FeCN 6 times 4 minus. Let X be the oxidation state of Fe here, plus 6 cyanide ligands. Each one is having -1 oxidation state into 6 equals overall charge of -4. So X minus 6 equals -4. X equals -4 and this -6 will become +6 when it comes to this side. That is +2. Fe will be in its +2 oxidation state in this complex. So let us draw the orbital diagram. Four P, 4s, 3d. What will happen when Fe becomes +2? These Fe2 plus will not be having these 4s electrons. It is +2. 2 electrons have to go, that too from the outermost orbital. So Fe will be having 3d6 configuration. Fe2 plus will be having 3d6 configuration. That means 3, 4, 5, 6. This is 3d6. And the approaching ligands are in FeCN6 cyanide Cn. It is again a strong field ligand. They will make these electrons pair up. That means these 6 electrons in the 3d orbital will come together. They will come like 3d6 will be the configuration, but they will come together, pair up. So no unpaired electrons are there, and the hybridization will be D2sp3, and the complex will be diamagnetic. That is FeCN6 4- will be diamagnetic, since there are no unpaired electrons in its orbital. So of all these four complexes, we saw that only one is paramagnetic, and that is CrNH3 6 times 3 plus. That is the only paramagnetic complex. So let us find Cr. This one is this is diamagnetic, this is diamagnetic. CrNH3 6 times 3 plus. This is the one complex which is paramagnetic.